Hello and welcome back to Physics Safari. My name is Abhishek and today I'm going to discuss with you a little bit about the binomial expansion. So yesterday I've discussed with you about the trigonometry. I'm sure you guys must have seen that video. That was important. Now, in the binomial expansion we shall not discuss entire thing that we have to study in maths, but only few things which is relevant to the physics and the requirement of physics. So the first thing first, let's say if I have expansion of a plus b to the power of n, how are we going to do that? Now, according to the binomial expansion, this one is given as nc0 a to the power of n plus nc1 a to the power of n minus 1 times b to the power of 1. The next term is going to be nc2 a to the power of n minus 2 and b plus to the power of 2. Going forward, if I go to the one more term, nc3 a raised to the power of n minus 3 and b raised to the power of 3 plus so on till we reach, let's say, ncn a to the power of 0 and b to the power of n. Now one thing you can notice, the power of a is decreasing by 1 unit, whereas the power of b is increasing by 1 unit. So overall the sum of the powers of a and b is going to be n itself. And if I look at the number of terms in this entire expansion, then that is going to be n plus 1. We're going to have n plus 1 number of terms in this entire expansion. Well, this is valid for n as a positive integer. What we need in physics is more about assumptions. There are going to be very much situations in which we have to do a lot of assumptions. I'm going to share a couple of examples with you regarding that as well. But for now, let's say if I take a equals 1 and b equals n, and then let's see what is going to happen to this expansion. If a is 1 and b equals to n, okay, let's say b equals to x, my bad. If I choose b as x, then this entire thing is going to be 1 plus x to the power of n. Now you must know what is the meaning of nc0, nc1 and nc2 and stuff like that. So for that you should be aware of the fact that NCR is given as n factorial upon n minus r factorial times r factorial. I hope this part is visible. Now what is the meaning of factorial? Factorial is all about multiplying the term to its preceding term until we reach to 1. So let's say for example if I say maybe here 5 factorial, well that is all about 5 times, 4 times, 3 times, 2 times 1, and then we're going to stop. That's the meaning of 5 factorial, which is going to be how much? 120, of course. All good? Now, so yeah, let's use this. Just for your info, nc0 is going to be n factorial upon n minus 0, which is going to be n factorial itself. And guys, 0 factorial is 1. So that would be cancelled and this is going to give you 1. One more thing I would like to add over here. NCR and NCn minus r are both going to be equal. What exactly I mean by saying this? If I have, let's say, 5c2, then that should be equals to 5c. 5 minus 2 is how much? 3. That's what I mean by this, that NCR is going to be equals to NCn minus r. Now let us use this over here. NC0 is how much? 1. 1 to the power of 1 is going to be 1 itself. Let it be. NC1 is going to be your n. C1 is going to be n. A being 1, 1 raised to the power of anything makes no difference. B is x, x to the power of 1. So it's going to be x. Plus NC2, if you solve it, you'll be getting n times n minus 1. And we'll have 2 factorial in denominator. And here we're going to have x square. And the next term for this one is going to be n times of n minus 1, n minus 2 upon 3 factorial. You can actually solve it, if you want. You can just use this NCR theorem formula and you can try, you'll be getting this only. That's not going to be a problem. Now, so here we have 1 plus x to the power of n. It could be given like this. Now, the assumption that we need to do in physics is if this x is in between. So when x lies between 1 and minus 1, that means it is a small value. You know that if you increase the power of the smaller value which is lying between -1 and 1, the value would decrease. The value is going to decrease. Let's say for example, if you have, let's suppose 1 upon 2. If I raise the power, it's going to be how much? 1 upon 4, which is further smaller than 1 by 2. If you, let's say, 1 upon 2 to the power of 3 is going to be 1 upon 8, which is further smaller than 1 upon 4. So when you increase the power of a number which is between -1 and 1, the value would decrease. So when x is lying between -1 and 1, we sort of eliminate or ignore these. And in fact, this is a higher power. So we ignore the higher power. Higher power is ignored. Higher power is ignored. Right? The reason being, they are very small, and if you add small values, makes no much difference. Like 2 plus 0.009 makes no difference to it. It's going to be 0.2, 0.009 only. So this for x which is lying between -1 and 1, so it's going to be 1 plus x to the power of n. For x between -1 and 1 is going to be equals to 1 plus nx, and this is what you guys have to understand and remember. There are going to be a lot of assumptions based on this that would come to you. All good? Now, there are going to be few cases. I hope you have noted it down. If you have not, you can pause the video and just sort of note it down. Well, that's an advantage. Anyways, so let's say if n is probably a negative value or something, then I would have something like 1 plus x raised to the power of minus x. Then this is going to be 1 minus nx, as simple as that. This could also be applied when we have, let's say, 1 minus x to the power of n. In that case, I'm going to have 1 minus nx, and if I have 1 minus x raised to the power of minus n, this is going to be 1 plus nx. I mean, like these things, you can keep it in mind. Going to be useful while solving some expansion. Okay, having done this, I'm sure you guys have noted it down. If not, quickly note it down. Important one. All good? Now, so let us see some examples based on this. Let's have an example based on this and see the kind of question that would come to you. Now let us see some examples. Probably, maybe we can have this one. Let's say if I want you to find the sort of value for this one, 1001 to the power of 1 by 3. Okay, so let us use the binomial expansion to do this question. Probably what I'm going to do is, I would just write this as maybe 1000 plus 1 to the raised to the power of 1 upon 3. 1000 cube root is going to be 10. So easily I can take this 10 out. So I'm going to have 10, and inside I'm going to have 1 upon sort of 1000 to the power of 1 by 3. Looks good to me. This becomes a pretty small value. That's going to be 10 times 1 plus decimal 001. That is a smaller value. That's very much small. So this helps me, this reminds me a fact that, I can use 1 plus x to the power of n as 1 plus n times of x, provided x lies in between -1 and 1. And that's exactly what's happening over here, right? It is lying in between how much? Probably it's less than 1 and more than -1 for sure. So can I say this is going to be, this could be written as how much? 10 times of 1 plus, the value of n is how much? 1 upon 3. If you look at this, it's going to be 1 upon 3. So 1 upon 3 times x is how much? 0.001. And if you further divide this, this is going to give you, let's suppose 1 plus, 0 times 0, 0, 3, 3, 3, and it's going to keep on moving. So it should be 10 times of 1.00333 and so on, so on, so on. And once we open the bracket, this is going to give you 10.0, probably we have, okay, so 0, 0, I should be having one more 0. My bad, I just missed out 1 0 over here. Too many zeros. Okay, so we have 10.00, okay, and this time I'm giving extra 0. All right, okay. So this is how, we can get the answer. So answer is going to be 10.0033, and because this 3 can keep on moving, okay. I'm just stopping it there. There's no need to just go forward. All good? So likewise, you can actually get a lot of examples like this. Maybe they might ask you to sort of, you can take an example as a homework. Let's say this is homework. You can say, expand this 1, 0, 0, maybe I would write 2 raised to the power of 1 by 4. Try this as your homework. Just understand the same thing that we've done just now, you apply that. All good? Now, let's say we can go for let's say one more example. Okay. I'm gonna erase this. Okay, I'm gonna erase this. All right. Okay. Here we have. So we all know that the acceleration due to gravity, once we go up till a certain height, it varies, right? So let's say the acceleration due to gravity, we know that it's going to be given as gr square upon r plus h whole square. That's how it goes, you know, that's how it's given. It varies with the height. Once you go up or go down, it will vary with the height. For a value of h which is very, very lesser than r, we can do some sort of assumptions, and if I ask you to prove that this is equals to g times of 1 minus 2 h upon r. Yes, sounds good. I want you guys to prove this. For h which is very, very lesser than r, I'm like radius of the earth, you have to prove that a is going to be g times of 1 minus 2h upon r. All good. So same thing, you know, the moment I see this kind of stuff, h is very, very less than r, and if I know that if h upon r, if I put, that is going to be less than 1. So what we can do, again, first of all, let us try and simplify this. Let's try and simplify this one. Okay, so if I do it here, a could be written as what? G times of, I could get this r square in the denominator. If I could do that, because here also we have a square, so we can do some sort of manipulations. So okay, let me just write it here. G upon, this would be how much? R plus h, and since that is also square, so that would come inside, and whole square I can write, isn't it? Okay, so well and good. So going forward, so this is going to be a times g upon r over r got cancel, 1 plus h upon r whole square. Okay, let me write this way. Now we know that h upon r is kind of lesser than 1 because h is quite less than r, and this is going to be more than a negative 1 for sure. So I can apply which formula? I can apply 1 plus x to the power of n is going to be 1 plus n times of x. This assumption is going to work handy over here. So this a is going to be written as what? G times 1 plus h upon r to the power of minus 2. If you remember, just now we have done, if you have a 1 plus x to the power of minus n, this should be on minus nx, isn't it, guys? So this part I would simply write as g 1, which is over here, n is how much? 2, h, I mean like x is how much? H by r over here. So see, this is proof. That's what we're trying to, you know, look for, isn't it? So yeah, I mean like we can have various such assumptions. That's the reason why we use this in physics. We should be knowing it. Okay, let's say if I say that ET's temperature is given as maybe q times of 1 plus delta x probably by x minus 1. So let's say this is the temperature, that is how it is written over there, and I want you guys to sort of simplify, knowing the fact that delta x is going to be very, very small. So okay, maybe I can yes, I can raise the power. No? Let's say I raise the power of maybe 3 over here. Now it becomes okay, because if I don't raise the power, this 1 will automatically get cancelled. So maybe this could be your next example. As all we can see over here, delta x definitely is going to be very, very less than x. Even if it is just less than x, delta x upon x is going to be less than 1 and should be more than minus 1. I don't know if its part is coming in the recording or not. Anyways, let's say, we can just check that later on. Now here we have, so this is going to be how much? 1 plus 3 times of delta x upon x, negative 1 times of your heat q. 1 get cancelled. What I'm having is q times of 3 delta x upon x, isn't it? So these all things would be required when we do a lot of questions in physics, you know, assumptions would be there precisely. So these assumptions would be required. So yeah, I'm like, that's it from this. We can also learn, because I'm going to also help you to write down some expansion, which is going to be commonly used. Let's say, for example, expansion of a to the power of x, a to the power of x, log of 1 plus x and stuff like that. And yeah, sin x and cos x, essential part. Okay, so let's just write a few expansion which is helpful. Standard expansion, standard expansion, widely used in many cases. Number one, a to the power of x. So this should be written as how much? 1 plus x square upon 2 factorial plus x cube upon 3 factorial, and so on, so on, so on. All good? Number two, a to the power of x. That will be given as 1 plus x log of a plus we're going to raise the power of x, that's going to be x square upon 2 factorial, and even we'll have log a whole square, and the next is going to be x cube upon 3 factorial log of a to the power of 3, and so on, so on, so on we'll have. Okay, now what else we can know? So fair enough, we can also talk about, maybe we can talk about sine to the power of sine x. Well, sine x is all about the odd powers of x that we talk about, and in this case we have, let's suppose x to the power of 1 is going to be x. We have the alternate sign plus minus. We have x to the power of 3. Down we'll have 3 factorials, and so on going on. Going forward, we'll be having the next odd power. Even power will be sort of not counted in this. Even power would come in the cos one. That's why you can remember it. So sin x is going to be x minus x cubed by 3 factorial. We'll have plus x to the power of 5 upon 5 factorial. Now it was plus. We can have minus x to the power of 7 by 7 factorial, and so on, so on, so on. And the next one, maybe we can say cos of x. So the cos x deals with the even power of x. So if we have x to the power of 0, 0 being an even number, you guys should be aware of that. 0 is a even number, is an even number. So here we have, let's say, x to the power of 0, that would be how much? 1 minus next even number x square 2 factorial plus next 4 factorial, and okay, we're going to have minus sign. X to the power of 6 factorial plus, and so on, so on, so on. Well, in electrostatic in the next year also, in various cases in class 11, you will be having this expansion that would just come to you. Achha, one more I should help you with, log of, let's suppose, 1 plus x. This is going to be x plus sort of x log a. We have x log of a. Then the next term is going to be how much? We'll have the square of this. Increase the power x square, and we divided the factorials, and even this power should also be increased, like the way we have done over here. So here we have factorials, but here we'll not have the factorials. That's the only difference. Look at this. A to the power of x is going to be 1 plus x log a. Here I'm like, we do not have the 1 over here. I'm just telling you how you can sort of remember that. And one more thing, the sign changes would be there. So it is plus now, it's going to be minus, plus we'll have x square upon 2 factorial log a whole square. All good? Going further, we'll have minus and x cube by 3 factorial log a whole cube. So this is how the things goes over here. You can make some sort of similarities to remember, to memorize. These two looks kind of very much similar. These two somehow look similar, except this factorial things. I mean, like, sorry, this plus minus things. Almost everything is kind of same. And we have just 1, and here we have start with the x. So odd even power ka same chakra is here also. So okay, that would be much about this exponential expansion and all. Now, the next thing that we should discuss about is the differentiations and the integrations. So let me help you with the fundamental of differentiation. The integration part I'm going to discuss in the next, and that should be the end of it. We're not going to drag it a lot. Just only things that is required I will discuss. Later we'll discuss in the topics if it is required, and when we come across those topics. Next is the differentiation. So many wires. Okay, just a second, guys. Okay, great. So now the next is the differentiation. Differentiation. So for this, in maths we'll study about like limits, derivatives and all, first principle stuff like that we'll study. But just for you people, for the physics perspective, what we need to know is how we differentiate and what are the few differentiation of few special functions, and especially with the trigonometrical things, what are the fundamental differentiation or differential of the trigonometrical function. Okay, now if I have a y as a function, it is a continuous function. I want to find the rate of change of y with respect to x, the reason being y is a function of x. So I need to find dy upon dx. Okay, well this is called differentiation. In physics, when I'm going to talk about the average speed and velocity, the instantaneous velocity, these things would pop up over there. So this is given as what? D upon dx of f of x, alright? Now f of x could be anything. You can choose to have, let's suppose, as probably x squared plus maybe 2x, just a quadratic function. So this is going to be how much? D upon dx of x squared plus 2x plus 1. Now I need to know what I'm going to do after this. I just have no clue. So we should know some fundamental rules of differentiation. So for that, here we have d upon dx of x to the power of n is given as n times of x to the power raised n minus 1. As in, this power would come over here and this would go up there with a power of 1 less power. Now, if I have a constant, its differentiation is going to be 0 because of course the constant is not going to change, right? That will remain as it is. For example, let's say if I have d upon dx, change of 5 with a change in x. I mean, like, it's not going to change. The 5 is going to be 5 itself, no matter if x is 2, 5 or 220. All good? So yeah, this is how it's going to work out. One more thing I would like to add over here. If I have differentiation of a constant when accompanied with some variable, for example like this, you can actually take this constant outside because that is not going to be hampered with the differentiation. That is not changing, and the rest is going to be same as what we have done over here. All cool? Now, one example for this to demonstrate this one. If I have, let's suppose, d upon dx of x to the power of 4, then using this one I could say 4 times x to the power of 3. Now, if I use that relation over here, I should be getting how much? D upon dx. I can split these two. I'm going to have x squared. I can also split like d upon dx of sort of 2x plus d upon dx of 1. Now, using this rule, n is 2, so this is going to be how much? 2 times x plus this is going to be how much? Just 2, and the differentiation of constant is going to be 0. So finally what I'm going to get is 2x plus 2. So that is your dy by dx, having y as this much. So that's a fundamental of differentiation. Now, we're going to have certain rules for the differentiation for the trigonometrical functions, and they're going to be valid, be it in physics or be it in maths. So let me help you to write few trigonometrical differentiations. Number 1, d upon dx. You can actually get this in all the books. This is going to be sort of cos of x. Rule number 2, d upon dx of cos of x. This fellow is going to be minus sine of x. Rule number 3, let's say d upon dx of tan of x. This fellow is going to be secant square x. 3 fundamental rules, right? Okay, number 4, d upon dx of, let's suppose, I'm just telling you the basics, which is necessary. That would remain same. Number 5, differentiation of log, d upon dx of log of x. That would be 1 upon x. Right? There are so many things we have. Differentiation of probably e to the power of minus x, a to the power of x, and stuff like that. Well, differentiation is also called as anti-integration. So differentiation, what we do, we find the rate of change. Integration, we find the area that I'm going to discuss with you in the next video. Okay. Also, one more thing I would just like to add is over here is the log. A little bit about the log. Don't worry, I'm not going to teach you the details of the logs over here. Just the fundamental of logs. Let's say log is, if I say log of ax equals to b. Well, this is called the base, your exponents, that's the value. So, for example, log 2/8, that is going to be 3. So if you look at this one and this one, you can actually understand that this implies 2 to the power of 3 should be equals to 8. And if I use this analogy over here, I'm going to have a to the power of b, that should be equals to x. Look at this, similarities, right? Anyways, few rules of log you must be aware of. Now, log of a plus b, well, don't write that's log of a plus log of b, that's going to be completely incorrect. And if I just write, let's say, log of a plus log of b, and if I also write a log of a minus b as log of a minus log of b, trust me, this is going to be wrong. This is not the way it should be written. Then what is the right way of writing it? What is the correct way of writing it? So, this is the wrong one. This is the wrong way. A lot of times, a lot of people go wrong in this. So that's why I'm telling you, not a big deal. So here we have, let's suppose, log of a times of b. This is going to be written as log of a plus log of b. This is the correct one, guys. This is the correct one. At the same time, if we have log of a upon b, well, that is going to be log of a minus log of b. Well, these two are the correct one, and you should note it down. And keep that in mind. Don't mess out over here, okay? Don't mess out. Okay, few more things. Okay, let me just keep this tester here. About the logs that we should be knowing. Okay, maybe rule number 3 I can say. If I have y is equals to, let's say, log of m to the power of n, this would be written as n times of log of m. This just comes out, okay, and it would be written as it is. Vice versa is also true. If you have these two, you can work on it. Also, if I have y is equals to log of a on the base a itself, that's going to be 1. This is going to be, if these two are equal, this is going to be 1. What you guys going to see in the majority is going to be log of e, that's going to be 1 equals to log of base 10 equals to 1. Also, for the binomials, log of 2 is going to be 1. This is called engineer's log 10. This is also written as ln. So if you have ln x, automatically understand this is all about a log on the base e x. That's what it means by the ln e. Okay, so I think that should be okay. One more thing, if you want to add up, there's a lot of rules we have. E to the power of log of e x should be written as x. I'm just telling you only those rules which are sort of essential, which you will come across, or else we have the entire topics on log, we have entire topic on differentiation and stuff like that. Anyways, so yeah, that should be enough. One more thing in the differentiations, I'm going to teach you a couple of rules like u.v methods, differentiation of the implicit functions and stuff like that. Also followed by that, tomorrow I'm going to cover up in the next video the integrations. All good? So those things I'm keeping for one sort of videos because they both comes under the calculus category. So I'm keeping both of these in details for the next video. So yeah, that should be the last one, and then we're going to jump to the kinematics. I shall quickly start the kinematics. Okay. So yeah, thanks for watching, guys. I'm going to see you soon. Take care. Bye bye.